Hello again. We're moving on to lesson 4 of our first unit. This lesson is even versus odd functions. So we'll work with some definitions to start here. Odd functions graphically, it'll be everything on the left side of the axis line is opposite of everything on the right side. So what that means is if you move over 1 from the axis on the right side and you have an answer of positive 2, and then move over 1 to the left of the axis line, the answer will be negative 2. Okay. On a graph, it'll look like this, where it's the exact same. So this point is, let's say 2, 4. So this one will be negative 2, negative 4. Okay, graphically with even functions, everything on the left side of the axis line is the same as everything on the right. Okay, for this example, the easiest one we can think of is quadratics, right? You have an axis of symmetry, which means everything on the left is the same as everything on the right. So if this again was 2, 4, on the other side it will be negative 2 and 4. Okay, algebraically, odd functions, if we were to plug in negative x, okay, so you pick a number, let's say again 2, plug in negative 2, you will get the opposite of what you would normally get in your function. Okay, so an example here, if we're talking about a linear line, so the linear line y equals 2x. Let's make it easy. So if we plug in regular x, let's make x equal 2. We get 2 times 2, which is 4. But in an odd function, when you plug in negative 2, 2 times negative 2, we get negative 4. Okay, so it's the opposite of what the original function would give you. For even, when you plug in the negative of x, you still get the original answer. Okay, so if we're working with y equals 2x squared, okay, when x is 2, y equals 2 times 2 squared, which is 2 times 4, we get 8. But if we work with plugging in negative 2, y equals negative 2 squared, which is still 2 times positive 4, giving us positive 8. So that would make an even function. Okay, determine whether the following functions are even, odd, or neither. So in order to do this, instead of f of x, we're going to plug in f of negative x. So we literally make the x's negative. So this x squared will be negative x squared plus 5. And negative x squared gives us x squared plus 5. And now it's the same as the original function. So therefore, this is even. Right? We plugged in negative x and ended up with the original function. Okay, if we plug in negative x to this one, we get 2 times negative x cubed plus 5 times negative x. So negative x cubed stays negative. Right, so we have negative 2x cubed, minus 5x. We can see that it is the complete opposite of the original function, so this is odd. Okay, let's try this one. So again, we're always just plugging in negative x. So here we get 8x squared, negative 9 times negative 9 times negative x is positive 9x. So it's not the complete opposite of the original function, but it's it also isn't identical to the original function. So this one will be neither. Okay, j of negative x is 4 over 3 times negative x, which gives us 4 over negative 3x, which is the opposite. The first one was positive 4 over 3x. This is positive 4 over negative 3x. So therefore it's odd. Okay, plugging in our negative x, we get negative 5x over x squared plus 2. So the only difference is the numerator went from positive to negative, making the entire fraction go from positive to negative. So we have an odd function. And finally, an exponential. So we're plugging in negative x into our exponent. And we all know from exponent laws, a negative exponent means find the reciprocal. So it is the reciprocal of the original function, which is not the opposite. It is also not identical, so this will be neither. Okay, hopefully that makes